See if it doesn't
Lehan,
that.
take 4. So Annie, I moved this a little closer. We'll see if that's better. Is that in your way? Or too distracting? All right. Well, we'll see. I'll talk to you after class and see how it goes. But yeah, 4 valence electrons for carbon. Good. That's why it forms 4 bonds. What type of bonding? Organic. Covalent. Specifically, nonpolar. What type of forces does it have? Dispersion.
Wait. When you talk about bars, that means like the little
Dashes.
things.
Yep. Yep. Organic, weak or strong compounds. Weak, that means low melting, low boiling point. Desiree, please tell me the relationship between boiling point and the number of carbons in a hydrocarbon. Very good, good job. It's a direct relationship. She said it perfect. More carbons, the higher the boiling point. We drew that graph yesterday. I think that's where we left off. Correct? I think the graph, yeah. All right, good. All right, who could give me the formula for octane? Who could give me, let's just do it out loud. You could write it if you want. But who could give me the molecular, you need your reference tables out, P and Q. Molecular formula for octane. Octane. John Todd.
C8H18.
Good. C8H18. So I just want to do this with you quick. If I say octane, that's OCT. That's the prefix for 8. And if I plug 8 in for the general equation or general formula for alkanes, I get 18. So you should be able to tell me 2 things. Or not tell me, but be able to write the formula from the name. And now, if I was to put this on the board, I would expect you to be able to name it and tell me that that thing is saturated. What do I mean saturated? Well, alkanes are saturated. What does that mean? They have single bonds. What does that mean? They have all their hydrogens they possibly can hold. So you should be able to take that and give me the name of it, tell me it's saturated, and I expect you to be able to draw all the bonds out. So 8 carbons in a row with all the hydrogens coming off of it. Okay? Your worksheet's going to practice that. So we're not going to hammer that anymore. So now we're going to learn something called branched alkanes. Branched alkanes. Branched alkanes. Morning. When I say branches, what do you guys think of? Trees, yes. So here's what I want you to think of. Think of the trunk of a tree as the straight chain alkane. So don't write this, just watch. So you have a whole bunch of carbons. I'm going to use blue, I think, today. My black one is running out. So if you have a bunch of carbons in a straight chain, think of that as like the trunk. It's actually called the parent chain. The parent chain, or the main carbon chain. It's another way to say it. So think of this as the trunk. Okay, trunk of the tree. Well, these alkanes have branches coming off of them. Okay? Those branches make these alkanes different than the alkanes we learned yesterday. So the alkanes that are in straight chain with just all their H's coming off of it, those are called straight chain. Branch is if you have carbons coming off the side of it. So these carbons are called the branches. So here's your branches, like here's your trunk, here's the branches coming off or breaking off, or however you want to use it. That's the concept here. So when I say branched alkane, I want you to think of something, instead of looking, well, that's going to be confusing. So instead of looking like this with all the carbons just in one chain, what happens is one hydrogen goes away, and then we take a carbon and put it here in the middle. So that would be a branch. These 4 carbons would be part of the main chain, and then this carbon here branching off is called the branch. It's also called a substituent. So we're going to write all this stuff down today, but I just wanted to intro with the general idea that a branched alkane has a main chain, or a parent chain it's called, and then you have branches coming off of it. So today we're going to learn how to draw these things and how to name these. So what we did yesterday is pretty straightforward using table P and Q. It's a little bit harder today. So we'll see how you do. Let me just fix this before I forget. Put my hydrogen back on. Oops. And then we'll talk about alkenes tomorrow. Or today, we'll see. There we go. Alright, so branched alkenes, let's write this down here, have a parent carbon chain with substituents. Substituents branching off. And another word for a substituent is called an alkyl group. Alkyl group. You're going to learn some weird words today. But that's right. So, parent carbon chain. They say parent because that's like the main part of the compound or the molecule. Sometimes they call it the backbone, the carbon backbone. So think of your backbone. What branches off of it? Everything else, right? So that's the concept there. So what is the branched alkene? That is the kind of definition or explanation. We're going to figure out what these are today. Substituents and alkyl group. A substituent in real life, how do we use that word? A substituent. Usually we use it to explain, or we use it in a way to explain that it's something that's part of something bigger. So a substituent is part of something bigger. So you can almost say, okay, in the Burn-Knox-Westerlo School District, the middle school, high school is one substituent, and the elementary is another substituent. So we're parts of a bigger picture, right? So that's what a substituent is, and those are the branches that come off. So the best way to learn this is just do some examples. But first, I have to give you the basic basic structures of these things. So a substituent and an alkyl group mean the same thing. And what are those? Here they are. So here we go. So the substituents / alkyl groups. I know some of you are probably like off in la la land because you're confused, but you'll be back. Just stay with me. Stay with me. There's really only two. I'll give you three, but there's only two. There's only two that you really need to know. The first one's called a methyl group. Second one's called an ethyl group. Oops. Ethyl group. And guess what the third one's called, which is, this pull a star, it's not as common. Guess what the third one's called? Propyl group. Good.
What are we even talking about right now?
Propyl group. Zane knows.
Gotcha.
You have no idea what you're talking about. You're just copying it down for now, and then we're going to use what we copied down to learn it. I realize that. So it's like I'm giving you a toolbox with a bunch of tools that you've never seen before. Now I'm going to take those with you and show you how to use them. I know that. Does the analogy help a little bit? You have all this stuff, you don't know what it does, but I'm going to show you how to use it. Okay, so methyl group is a CH3. Or, if you want to draw all the bonds, it looks like this. C with 3 H's coming off it. So this thing right here, this right here is a methyl group. It's a carbon that doesn't have all of its bonds. It only has 3. It has 3 bonds to 3 hydrogens. 1 bond is left exposed. That bond is going to be attached to a chain. That's the substituent. So we're going to take this and stick it on a chain. This is called a methyl group. There's nothing fancy about it. I know it's confusing. That's what a methyl group is. It's a CH3. That's what it is. An ethyl group is a CH2CH3. Or, if you want to draw the bonds, it's CH2 bonded to a CH3. And that CH2 is not complete. Here's an ethyl group. See how that stick is there without anything on it? That's because it hasn't bonded yet. So there's 5 hydrogens, 3 here and 2 there. 2 carbons. That's an ethyl group. So we're going to take this and stick it on a chain. So this is called an ethyl group. This is one of the branches that would be hanging off our trunk. Okay? So this is an ethyl group. This is an ethyl group. And then propyl would be 3 carbons. CH2, CH2, CH3. I don't feel like drawing it all out because that one's not common at all, so I'm not too worried about you guys fully grasping the propyl. But here's the propyl. So there's a propyl group. So it's an alkane, but it's missing one atom. That's what it is. It's missing one. Therefore, we can take that bond and stick it on a chain. So this is called a propyl, because 1, 2, 3 means prop, right? Propyl group. So there's your propyl group. Again, this is a branch. These are 3 branches that can come off of the main chain. And of course you're confused. I know that. Okay? We're going to take this information now, and we're going to use it to try and figure out what the heck is going on. Okay? But I promise you, I've been doing this a long time. Every year, kids have the same reaction. I don't know what's going on. And then we do it for a little while, and everybody gets it. Everybody always gets it. All right? So I promise you'll get there. Here we go. So I'm going to give you a name, and then I'm going to give you a structure. And we're going to do them both together, and I'll show you how this stuff works. So here we go. Write this down. 2-methyl butane. Just write it. I know that sounds like a different language. It's kind of sounds weird. Just write it. 2-methyl butane. Put that over somewhere. It doesn't matter where, I guess. But then next to it or underneath it, if you're going to write underneath, leave space because I'm going to draw a structure here. So next to it, I'm going to give you a structure, and then we're going to name it. So I want you to draw exactly what I'm drawing. Draw exactly what I'm drawing. Just like I'm drawing it. And just for fun, I'm going to put next to it the condensed version. So those two are identical structures. I just did condensed versus structural. I want you to see the difference. So those two are the same. All right. So here's what we're going to do. I'll give you one more minute. Make sure you got it. Okay, so now what we're going to do, we are going to take that 2-methylbutane and I'm going to show you how to draw the structure for it. So what you're going to be able to do before you leave here today, if I give you the name, you're going to draw that. And then vice versa. If I give you this, you're going to give me the name. That's the goal today. We got enough time. 12, 13 minutes, plenty of time. Here we go. I need your undivided attention though. You really gotta try to learn this. You can't just sit here and say, I don't get it, and then that's it. You gotta put effort, mental energy in. So here we go. We work backwards. When I give you the name, we work backwards. We don't start with the 2, start with the butane. So here's what we do. Butane. How many carbons are in butane? 4. If you don't know, you go to table P. Look at the prefix. Meth, eth, pro, bute. Bute means 4. So now we draw butane as if this 2-methyl was not there. You just draw butane. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure you have 4 lines coming off of each carbon. 4 lines off of each carbon, right? 4 lines, 4 bonds. So again, you're staying with me now. I'm going nice and slow. You write butane. You draw butane. Now you go to your list of substituents. Because that is a substituent. How do I know? It ends in a YL. That's why it's called an alkyl group. It's just the name of it. Don't worry about the name alkyl. Don't try and learn everything all at one time. Just stay with me each step of the way here. So you know what butane is, you write it down. Draw. Methyl. Go to your notes. Look up methyl. What is a methyl? What is the structure of a methyl? CH3. So methyl is CH3. A C with 3 H's. So we need to branch off one of these bonds here. We have to have a branch. What is that branch? It's a methyl group. Guess what the 2 tells us? Which carbon to put it on. So you number these carbons. This is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. But if Kai wanted to number it from the right, he could do that. You could do either direction. You could say this is 1, 2, 3, 4, or 1, 2, 3, 4. Here's why it doesn't matter. These things actually exist in real life. I can turn this, I can rotate it. It doesn't really matter if that's carbon 1 or 3. That's always carbon 2, it's in the middle. But that could be 1, that could be 1. It doesn't matter. So I'm going to stay left to right, because I think that probably is what everybody was more inclined to do. So number 1, number 2, number 3, number 4. This 2 tells me this methyl group here, is right here, or right off of this carbon. I can stick it up here, or I can stick it down here, it doesn't matter. So I put a C here with 3 H's coming off of it. There's my methyl group. That's my methyl group. And then I have to fill in all my other H's. And that structure has the name 2-methylbutane. 2-methylbutane. Okay, let's go to this one. Now we have to name it. So you're going to come up with something like this. Here's the rule. Please stay with me. Sydney, pick your head up. Please stay with me. First rule, count the longest carbon chain. What does that mean? I have 1, 2, 3 in a chain. I also have 1, 2, 3 in a chain. I also have 1, 2, 3 in a chain. I made this one easy. It doesn't matter how you count it. The longest connected chain of carbons is 3. Okay? So whether a 3 looks like this, or if I twist it and the 3 looks like that, it doesn't matter. If the 3 are connected, it doesn't matter how it looks. So you count the longest connected carbon chain. Put a box around it. Everybody do this. This is how you learn this. Now, name what's inside the box and only inside the box. How many carbons are in the box? 3. What's the prefix for 3? Pro. Single bond, so only single bond. So we know it's an alkane, so it's propane. It's propane. Now, anything outside the box that is not a hydrogen, a carbon, circle it. Now you have to name that. What is the name of a CH3? We just learned it. It's a methyl group. This and this are the same thing. It's a methyl group. Where do I write that name? In front. Methyl propane. So this is our methyl. Everyone, you need to write this down. This is our propane. So this is what you're going to have to do for homework. You're going to practice this. Anything inside the box, that's the main chain. That's the name that's going to end in ane or one of the hydrocarbons, mostly alkanes. The thing that we circle outside the box, that's the YL. And it's either going to be methyl or ethyl. That's it. Now, last thing you have to do is just like we did here. What number carbon is that on? Number 2. So the name of this is 2-methylpropane. 2-methylpropane. So I did an easy example, I think a little harder. They get harder than this. Questions? We're going to do a couple more right now.
Can there be more than one album?
Yes, there can. We're going to get to that here in a few minutes. Let's try another one. I'm going to do the same thing I just did with you, except I'm going to give you some time to do it on your own. I'm going to give you a name. I'm going to give you a structure. I want you to try and name it. Here we go. Or name it and draw it. So this one's going to be 3-methylpentane. I want you to try and draw that. And then I'll draw a structure over here, and you give me the name of it. I'm going to do, yeah, I'll do condense. I'll do structure. going to give you a couple minutes. I really want you to try and do this on your own first. Then I might have you commiserate with your people. And then we'll go over it. Then we'll squeeze one more, and then that'll be it. I can. This is a good time for me to walk around and check it out. Where are we? Good job. Chemistry. That time when someone was playing the game, yeah. Good job. It's okay. Everything's going good. Good. Okay, share with your neighbor. Oh, okay, well, Kayla said hold on. Anyone else? Share. Share with your neighbor. Tell them what you got. And if you disagree, then talk to each other about it. Come on up. Desiree wants to draw.
Can I do the second one?
Sure.
Listen, Zane, I never put up any of this stuff.
You can just use the red one to do what you need to do.
Can I just write it?
Yeah, whatever. Whatever you want to do. Sometimes I wonder about girls and women and their bags, what they really have in there.
It's a mystery to us.
Just because guys, you know, like,
It's a mystery.
basically if we can't fit it in our pocket, we
We
don't
don't
care.
take it.
Why do they have so many?
Some people carry it.
No, I know, it's a school. I know you use it for school. It's different. That's different.
Guys, it's like a phone in a wallet.
All right, here we go.
And you can put that.
However, I do rely on my wife sometimes to hold some things for me. So that does happen, and that's an advantage. I don't know why I'm thinking of that right now. Let's go back to this. So, you guys all did a good job. I walked around. Looked like you did a good job. This is very good. Again, pentane, stay with me. Pentane, 1, 2, 3, 4, 5. There's your pentane. 3-methyl, 1, 2, 3. Third carbon has a methyl group. Good job, good job. 2-methylhexane, also correct. Here's our hexane. There's our hexane. And then there's the methyl on the second carbon. Now, she could have, or I could have, drawn this carbon, I want to make this very clear, here. That's the same, because these things exist in real life, so they're three-dimensional, they move around. So the mirror image of this is what I just had. So just keep that in mind, okay? So you can count from either way, it doesn't matter, but here's the one rule. The carbon that's branched has to be the lowest number carbon possible. So you would never name this 1, 2, 3, 4, 5-methylhexane. You always go for the low. Always go for the lowest number. Yes? And the carbon can also be up top. Yes, that works too. It doesn't matter if it's up or down. Good. Okay, so you always go for the low. We'll talk more about that. Let me give you one more example, then I'll hand out the homework. Okay, here we go. Good job. Very good on that. Very good. Feel good about that. All right, let's do this one here. 1, 2, 3, 4. On this carbon, we're going to put one carbon up, one carbon down. And notice how I'm not labeling my hydrogens. I'll let you into the secret today. You don't have to either. But if you forget to label the bonds, it's wrong. So in other words, if you drew this like this, and just put the carbons, you get no credit on the readings. You have to show the bonds, okay? You got to show the bonds. You can leave the hydrogens off, but you got to show the bonds, okay? So, if I gave you this structure, we're going to do this together. What's the longest connected chain of carbons? Zach? 4. 1, 2, 3, 4. So here's our 4 carbons, single bonded. So what's the name of that part? Butane. Good. We circle everything outside the box. We have 2 carbons outside the box. We have a CH3 here and a CH3 here. They're both on carbon number 2. What are these called? Methyl. They're called methyl groups, right? Methyl. In your notes, CH3 is a methyl, right? So that's a methyl. This is a methyl. That's a methyl. Here's the name of this thing. It's 2,2-dimethylbutane. Stay with me. 2,2, here's why you have to write 2 twice. Because this one's on the second and this one's on the second. You got to write it both times because there's 2 of them. What's the prefix di mean? 2. You have 2 methyls. So 2,2 tells me the number it's on, number 2. And the di tells me there's 2 methyls. So 2,2-dimethylbutane.
But if there was one, like number 1 and then
So if there was one here and not here, stay with me, it would be 2,3-dimethyl. Because 2,3, this would be number 3. 2,3-dimethylbutane. Okay? Your homework's practicing this. Okay? Your homework's practicing that. Good job today. Don't forget that quiz. Tomorrow, and we'll be after school. So some of you who are